Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again. Thanks for joining us. This is the Space Nuts podcast, episode 252. Good grief. My name's Andrew Dunkley, your host. Joining me again, and as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How are you doing?
I am fine, thank you, sir. How are you?
I'm very well, thanks. You've got good news, haven't you, with a paperback out and things of that sort?
Oh, yes. I have finally finished the entire process of getting the book organised. The typesetting's done, the spell checker's done, the whole proofreading process is over. I think it's been proofread 3 times, and then we got it up to the publisher, we got the cover, everything's ready, and it will be released on May the 31st in paperback. This is the Hitler Paradox, and it's available now if you want to download the ebook. Now, you're going to love this, Fred, but we got everything done, everything checked, and yesterday I just thought, I'll just see, what's going on. It's popped up on Amazon in less than 24 hours of being sent to my distributor, which is quite extraordinary. It usually takes a while. That's in Australia and in at Amazon.com. I thought I'll just have a quick look and see how it all sort of came up on the interface, and I started reading through. I think there's a spelling error in the very first sentence. Never saw it. No one saw it. So I can't be bothered fixing it.
No.
It cost me $25 to fix one letter. I'm not going to worry about it. But it's out there. It's got rather a striking cover, and again, I say thanks to my brother Steve for coming up with the concept. It is, you won't miss it. It's quite in your face, but that's what I wanted, because this is a story that centres around 3 or 4 eras. It's sort of going to go all over the place in terms of time. Yes, it is a time travel story, but the basis is that in the 2200s, time travel is a reality. The United Nations of the year 2213, which is where the story starts, has decided that we're going to use this machine to right the wrongs of history. And the first thing they want to fix is the greatest travesty in humanity, and that is the Holocaust. And they decide the only way to do that is to kill Adolf Hitler before he became a somebody. And, of course, they fail. And when they fail, it awakens a new and more horrifying enemy, and that's basically the story. It's a race against time between what the people of the 2200s are doing against the enemy that is in the future, and they have to deal with it in the past. So that's how it all turns out. And, Fred, last week I read a post because I did a sort of preemptive notice on Facebook that the book was soon to be released, and someone said, "Oh, great! Can't wait to hear read the twist in this one." And I thought, "Oh, okay."
Did I put one in?
Better think of one. So I rewrote the end.
Oh, there you go. Good. Yeah.
So it's out there. It's ready to roll. Have a look for it. The Hitler Paradox. You'll find it. It'll start to pop up in more and more places. It'll be in all the regular bookshops online and ultimately in bookstores. But let me know what you think. And yes, I do plan to put an audio version out. I've just got to get around to recording it. It's a big job and a lot of hard work, and I hate editing. which is why I like podcasting, because we don't worry about that kind of thing.
We don't.
Now,
Somebody else does.
That aside, let's talk about today's show, and we're going to talk about. We've been talking about Mars a lot, and the rover that NASA's put there, Perseverance, and the Ingenuity helicopter. But now it's China's turn. They're about to land a probe on Mars and send out their own rover. So we'll talk about that. A new form of Aurora has been discovered. They just like has happened a few times recently, Fred, in our discussions, they found this in old data that they were reviewing and went, oh, hang on a minute, what's all this then? And yes, a new form of Aurora. And proof that life-related molecules can form in the cold, dark vacuum of space. So we'll look into that. And audience questions from Doug in Ontario and Sandy in Victoria, which we will get to a little later in the program. But first, Fred, notwithstanding the achievements of Perseverance and Ingenuity and NASA, China has been orbiting Mars from about the same time or a bit earlier than NASA was there in this case, and now they are ready to land on the Martian surface. And if they do, they will achieve history, because thus far only two nations, Russia and the United States, have achieved that.
That's correct. Yeah. The story goes back, and we covered all this back in February when Tianwen-1 became the second of the. Actually, we covered it last July. Tianwen-1 became the second of the three space probes that were launched to Mars back in July. The third was Perseverance. Perseverance, of course, in February went straight into entering Mars's atmosphere. It didn't go into orbit. It was meant as a straightforward lander, so the 7 minutes of terror were right at the end of that long voyage, but everything went perfectly well, and we've got, of course, as we all know, we've got both a helicopter and a rover on the surface. However, the Tianwen-1 probe, and by the way, Tianwen means questions to heaven, or maybe quest for heavenly truth. That's another way of putting it. It's a nice name. Yeah. Comes from a long poem, one of the great works of Chinese literature. So Tianwen-1 has on board its own lander, and the plan was always to orbit the planet for 3 or 4 months, just to make sure that everything's working, and also to select a suitable landing site, because the orbiter has cameras on board and all the rest of it. So that was always expected to be May, and it's May now. And the thinking is that within the next couple of weeks, perhaps, we'll see news of the lander going down to the surface. And I think after just a few days, it will unload the rover. The rover itself is called Zhurong, if that's how you pronounce it. It's named after an ancient fire god in Chinese mythology. They're all great names. So Zhurong will, it's a little 6-wheeled rover. It looks a lot like, excuse me, the Sojourner rover that NASA put on the surface of Mars in 1997, I think, if I remember rightly. 6 wheels, a couple of large solar panels on it to give it power, and festooned, of course, as always, with scientific equipment, including one that's never been sent to the surface of Mars before, and that is a magnetometer. Mars not having a global magnetic field is. It's never, we've never had something on the surface that can measure the magnetic field, but there is probably evidence locked up in the rocks of Mars's ancient magnetic field, if indeed it had one, so Zhurong will be perhaps one of the milestones in our understanding of the planet Mars, if it manages to measure a magnetic field and tell us a little bit about the magnetic history of the planet. It's great stuff.
Yeah, I think the other thing they're also looking into is what happened. What, not just the magnetic field, but the planet as a whole. What went wrong? Where did everything go? Why is it so Why is it so desolate?
Yeah, that's right.
Yeah.
Well, a lot of those questions have been answered already in terms of our understanding that's come from orbiters and landers on the surface, but there are still many, many details that we don't understand. One of them is, we all kind of believe that it's likely that at one stage in Mars's history, the northern hemisphere was covered with water, which is why it's flat and almost featureless now compared with the southern hemisphere. But we don't know whether that was an ocean that lasted for tens of millions of years, or whether it was just water that was relatively shallow and only lasted a short time, or even whether it was a lake underneath a huge ice cap on Mars, that it may, Mars may never have been the balmy, warm and pleasant place that we think it might have been, and certainly that the Earth is. It may have had an ice cap with water underneath it. So perhaps some of those answers will come from Zhurong. It's got the usual other stuff as well of analytical equipment to look at rocks and things of that sort. It's not that far from Perseverance, although certainly not within travelling distance. These things only do a few kilometres. But it's in the same hemisphere and in a similar region. But Perseverance is in a much more interesting spot from the point of view of trying to detect evidence of past life on Mars.
It looks like the entire area is popular, because when you look at them, they've published a map on one of the websites I'm looking at that shows where all the landers have put down on Mars in all the time we've been going there. And you've got Perseverance, you've got Zhurong, you've got Viking 2, Beagle 2, Insight, Curiosity, and not far away Spirit. They're all in that kind of vector, aren't they?
Yeah, they are. Yes, that's right. It's a region of Mars's surface that it's called Utopia Planitia, and it's actually probably a giant impact crater from Mars's really early history. But that's a region that's thought to be of geological interest on the planet, and that's why there's this, exactly as you've said, there's this cluster of. When you look on the map of where things have been sent to land, including the ones that didn't quite make it, there's a cluster of them around there.
Wow. Yeah, very true. A giant impact crater. So are we going to find dinosaur bones as a consequence of that?
Look,
unlikely.
It doesn't matter what kind of bone it was. A bone would be sensational.
A bone would be incredible. Yeah. But we'll have to wait and see. But yes, so who else is around there at the moment? That's just slipped my mind briefly.
In terms of active
orbiting Mars.
Oh, there's an Indian spacecraft.
That's right.
There is, of course, Hope, the UAE spacecraft, Tianwen-1. That's 3. Yep. There's Mars Reconnaissance Orbiter. There is ExoMars, the European one. I think that's 5. And the other one is, what's it called? Marvin, the atmospheric, and that's right. Atmospheric probe. 6 of them.
Yeah. It's almost getting as polluted around Mars as it is here.
Well, that's right. Yes, that's a good point, because there are inactive satellites as well, various ones that were active in the early years of the millennium, including some I can't remember their names. No, it's good stuff. And actually, right. Well, I've left one out, in fact, because Mars Express, the European ESO one, is still active too. So we're up to 7, I think. I better do a proper count.
That's incredible. Yeah, and to think, going back, 50 years or so, we were still trying to figure it all out, and here we are, sort of whizzing around Mars like it's like it's Manhattan traffic.
Yeah. So that's right. So fingers crossed for Zhurong's for the 7 minutes of terror that spacecraft will also have to experience to get down onto the surface of Mars.
Yeah, well, they proved they can put a rocket back on Earth. I mean, that they did that the other day, and did that end up landing in the Indian Ocean?
It was the Maldive Islands were the nearest land for where it landed. Yeah, but I've not seen any vision of it. I suspect it was somewhere where there were no ships and no no nearby land. And of course, it was daytime when that happened. Actually, it might have been small hours of the morning. It was, but it obviously, we've certainly not seen any footage of any kind.
No, which is probably a good thing. I mean, you don't want something like that landing in a populated area.
Exactly, that's right. Exactly.
Yes. Given that the planet's surface is, 70% water, the odds were pretty good that it would miss. But stranger things have happened, haven't
Indeed, they have, yeah.
Okay. We will watch, of course, with interest the Chinese mission on Mars with Zhurong, and we'll hopefully get some data from them real soon and be able to tell you what they've found. This is the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Just want to say hello to our patrons, the people who put their money into the Space Nuts podcast voluntarily. And we thank you very kindly for your generosity and your support of the Space Nuts podcast. And if you would like to become a patron, it's as simple as going to our website and clicking on the supporter button. And all the information you need to know is there, whether you want to do it through Patreon or Supercast or through PayPal as a one-off donation. It is certainly entirely up to you, as we keep reminding you it's voluntary. But we want to ultimately become 100% reliant on our audience. So to do that, we're going to need somewhere around 1,000 patrons. So we're slowly building those numbers up. So thank you if you've chosen to support us in some small way. And it's not expensive, but all the information you need is on our website. Just click on the supporter button to find out more. The other way you can support us, of course, is through the Space Nuts shop. A brand new book has popped up there this week, strangely enough, as well as many other publications from our colleagues within the Space Nuts fraternity. One, Fred Watson, and there are a couple of others there as well. So check them out. And, of course, all our Space Nuts memorabilia as well on the Space Nuts shop. That's on our website, spacenutspodcast.com. Now, Fred, let's move on to the next topic. And scientists have discovered a new phenomenon when it comes to Aurora, something that they didn't know existed. And this has been dug up in some old evidence, some old video. Now, what makes me laugh is they're referring to this old video. It's 2002. I mean, I can't get it through my head that stuff from 2002 is now considered old, but there it is. That's where the video came.
Look, it's part of history. It's antique stuff. Is this?
It is now.
Yeah, it is now. That's right. But it is remarkable that that we're still learning things about the aurora. Partly, Andrew, it's due to the fact that we have the technology now. We've got modern digital cameras that people can set up and do marvelous footage of auroral displays, and we see those all the time. If you look like looking at that kind of thing, which I do, but also the other thing is that, like me. As you know, I've led many tours up to the Northern Arctic to look at the aurora, and I think that's become much more of a commonplace thing. So a lot more people are going up to see the aurora borealis in the north. A lot more people go down to Tasmania to see the aurora australis in the south, and so more people are watching these phenomena.
Yes.
And
I'll tell you something, Fred. One of my golf partners, Darren, who I play with every Saturday, took one of those Qantas flights to nowhere recently.
Oh, right. Yes, yep.
And it took them down to Antarctica, and they got to see the aurora australis.
Very good.
While they were flying down there. So, and this has been a consequence of COVID-19 because the airlines have been hit so hard due to travel bans. Yep. They've had to diversify. And so airlines in Australia have been doing these flights to nowhere. So they were in the air for something like 10 hours to fly down there, have a look around, and then fly back, which is rather extraordinary. But, that's a side note. But they got to see the aurora australis.
But reflects the popularity of hunting aurorae, which used to be something that you only read about in books. And you and I have talked about some of the new phenomena that have been introduced. There was one not long ago, which were kind of Ripley aurorae, and then there were the Steves as well. I don't know whether you remember the Steves,
That's right.
which are now recognised as being a phenomenon related to aurorae, but not actually the same thing. So we've now got something quite new, which comes from this old footage, as you've said. This research has come from scientists at the University of Calgary, University of Iowa, and NASA too. The phenomenon is that, unlike many aurorae, which form curtains, and that's exactly what they look like in the sky, or streamers across the sky, or sometimes the best ones are what they call a corona, where the thing explodes above your head. Is it an extraordinary experience standing underneath something doing that? But there is another, it's a well-known auroral phenomenon, and that is what's called the diffuse auroral glow. And it's basically an aurora. It's green, but it's spread fairly evenly across the sky. It's not in these streamers and things. The new phenomenon is that this footage revealed that within the diffuse glow, so if you imagine this green glow over a large area of the sky, and suddenly a small chunk of it brightens up, and stays bright for a few minutes, and then it disappears. But where it was leaves a hole in the diffuse auroral glow. It's just black underneath. It's almost as though it's rubbed it out. And that's why they've been called, what are they calling them? The diffuse auroral erasers, because it's just like using an eraser to rub out the background aurora. And basically, it's a mystery. These scientists who are well versed in the field of auroral studies have no idea what's causing them. One of the astronomers at the University of Iowa says it raises the question: are these a common phenomenon that has been overlooked, or are they rare? Knowing they exist means there is a process that is creating them, and it may be a process we haven't started to look at yet because we never knew they were happening until now. So
that's amazing.
It's great stuff, and it's learning something else about our own planet. In fact, let alone the rest of the universe, it's finding out what's going on up here. So,
we know what causes aurorae, but obviously there are varying types, and sometimes we don't understand why certain things are happening to them.
Exactly. The mechanisms of the aurora, even just the straightforward aurora that we understand, is fairly complex. And it goes back, our understanding of it goes back to the turn of the 20th century when Christian Birkeland, a well-known Norwegian scientist who's a big hero of mine, he spent the whole winter on top of a mountain, which I've been very close to, near Alta in northern Norway. This mountain's called Halde. He wintered out over there with a couple of colleagues, one of whom didn't survive because the winters are pretty serious up there. But he was the first to sort of really show that the aurora it doesn't touch the ground, because before that people didn't know whether these dancing lights actually start at the ground level. And he also worked out that it was electrons from the sun that actually did the trick, but it was 50 years before anybody believed him, or 50 years after his death.
Yeah.
So, we're still learning, and I think this is one to watch. We might talk about this again, Andrew.
Okay, we'll keep an eye on that one. Let's now talk about the proof that life-related molecules can form in the vacuum of space. This is a new discovery as well.
It's a bit more subtle than that, because we've known for a long time that these molecules form in the cold, dark clouds that are where solar systems start, giant molecular clouds. And so the particular one in question is methanol. For the nerds, it's CH3OH, sometimes known as methyl alcohol. That's what they called it when I was at school. Methanol is certainly a precursor for life. We have methanol in our bodies, actually. It's one of the constituents of amino acids and hence proteins, things of that sort. So where it's been observed so far has always been in cold places, and cold is what you need for molecules to form, because warming them up inside a star, for example, tends to shake the individual atoms apart, and you don't see them. So we've known for a long time. We see them in comets as well, which are, as you know, icy bodies. But the new discovery, which comes from ALMA, our old friend ALMA, the Atacama Large Submillimeter Array up in the Chilean Andes, and this is work that's actually been done at Leiden University, or Leiden in the Netherlands. The work is, and this is what makes it different, that they've observed a warm region around a star, and it's what's called a protoplanetary disk, where you've got swirling dust and gas, out of which planets are forming. Our solar system looked like this 4.6 billion years ago, and we observe them elsewhere in space. So they've observed one of these warm planet-forming disks, but what they've found in it is methanol, and apparently methanol cannot form in this sort of warm environment. And so what they're saying is the methanol was actually formed somewhere else, and that's not a surprise because that's where the other places that we see it, these cold clouds. But the fact that it has found its way into a warm disk of gas around a star is what they're quoting as saying it could give the development of life a flying start, because it's there already. It's sort of in the raw material that these planets might be made of. And so, that's why there's a lot of interest in this story. It's basically spurned these researchers on to look in even more detail in this protoplanetary disk, because they're hoping that they might find other oxygen-containing organic molecules, like dimethyl ether. It's hard to say some of these, and methyl formate and acetaldehyde. These are all chemicals that, once again, they're as they say, they're key ingredients for prebiotic chemistry. So really interesting stuff going on in our understanding of these young solar systems and what they might contain.
So this would be another clue into how life might evolve in a system like ours, for example. In the early days when we were, just being mashed together, coming out of those cold climates of the universe, and started to warm up, we'd already received the raw materials we needed to create life. Is that what this is suggesting?
That's right. Yeah, exactly. The raw materials are there from a very early stage in the formation of a solar system, and that's interesting stuff.
Yeah. See, I told you. I knew it. I've said all along that I believe that the stuff of life exists everywhere, and it's just a case of the environment being exactly right to make it flourish. Otherwise, it just floats around out there being useless to itself.
I think that's probably right. Yeah. The Dunkley theory of prebiotic chemistry, which is, it's a good one.
Yeah, I dumbed it down real good.
Oh dear, so do I.
Well, it helps me. This is the Space Nuts podcast. Andrew Dunkley and, of course, Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, hello to our social media followers, who are many. The Space Nuts podcast group on Facebook is one such page that you can join. It's for people who are Space Nuts followers who want to talk to each other. It's run by the listeners themselves. So if you would like to join the 1,800 plus people who are already members of the Space Nuts podcast group, that's where you go. Just do a search in your Facebook search engine for Space Nuts Podcast Group. Of course, there's an official Space Nuts Podcast Facebook page as well, which you can also follow, or you can follow us on YouTube. we have a presence there, and you can not only listen but watch. If you really want to do that, why would you want to look at us? I don't know. But anyway, that's an option, and plenty of other places that you can find us. Of course, we've got our own website, which I mentioned earlier as well. So there are plenty of places to find us. And as far as the podcast platforms are concerned, we're on everything. So whatever platform you use, you'll probably find the Space Nuts podcast there as well. Now, Fred, we have some questions to tackle. The first one is in text form. This comes from Doug. Hi, gents. This is Doug. How about that? I got it right. From Whitby in Ontario, Canada. Thanks very much for the show. It's been great for helping maintain our relative sanity in the last year or so. Yeah, I can understand that. I particularly enjoy listening during long walks with my dog Hazel. Your show is just the right length, and of course, the content is very informative. My question is, if dark matter is, say, 4 to 5 times more prevalent than regular matter in the universe and only interacts via gravity, why doesn't it seem to have any effect on spacecraft navigation within the solar system? If it's clumpy elsewhere or mostly found in galactic halos. Thanks very much. Look forward to hearing your answer. Thank you, Doug. We don't get dark matter questions very often, Fred, do we?
That's a good one, is this?
Look, the fact of the matter is that this is such a big mystery. Yeah. People keep thinking of angles and ideas in regard to what could be going on. And obviously Doug's thought of something that doesn't stack up. And that's half the problem with this. It doesn't stack up.
And in fact, what we understand to be happening is exactly what Doug says, that it's only clumpy on very, very large scales. So if you think of there being a background in the solar system of this dark matter, whatever it is, these subatomic particles whose identity is unknown and only reveals itself by the gravitational effect that it has on other bodies. If you imagine that spread perfectly evenly throughout the solar system, then you're not going to know it's there from looking at the way spacecraft behave, from looking at the way planets behave. All of that ties in absolutely completely with every T crossed and every I dotted with both Newtonian and higher gravitational densities, Einsteinian or relativistic gravitational mechanics. It all works perfectly. It fits perfectly. And that's why we haven't discovered this stuff by just looking in the solar system. So we sit probably within a very, very uniform cloud of dark matter. And it's only, again, as Doug mentions, when you get to the scale of the halos of galaxies, that you can start to see its distribution. Excuse me. Now, I was involved a few years ago with some work. You might remember I used to be the project manager for the RAVE survey, the radial velocity experiment, which is something that looked for, it was measuring the velocities of stars as well as their chemical compositions and things like that. We did 500,000 stars in the end. It's brought to an end now. We finished in 2013. But one of the things that came out of that was the estimate that clumps of dark matter can't be any smaller than about 1,000 light years across. And that's partly from the kind of things that we've been talking about now, that, you know, the way the dynamics of stars operates. So that is not, it's not a firm answer, but 1,000 light years was for a while being tossed around as the minimum size of a blob of dark matter. And of course, you know, our solar system, the scale is measured in light minutes. So it's a much smaller scale. So I think exactly as Doug says, that's the answer, that we only see it when we look on the scale of galaxies. The fact that galaxies are probably immersed in these large halos of dark matter, which might be lumpier on a scale of 1,000 light years or so. that is that's what holds galaxies together. That's the point I was going to make, because one of the reasons why we think dark matter is there is that galaxies don't rip themselves apart as they rotate, so that the dark matter halo is what holds them together. There might be clumps within that, as I said, probably no smaller though than 1,000 light years, and they may even be much bigger than that. We really don't know too well.
Yeah. Do you think we'll ever crack it? Will there be a light bulb moment, or should I say a black light moment?
Yeah, a dark light moment. Yes, I think there will. There are two ways this could go. One is that some physics experiment, and there are ones where there are hints of this, although it's highly disputed. Some physics experiment turns up something that says, well, the standard model doesn't account for this of particle physics. There must be something else, and that leads to an opening where people start looking at energies in the particle physics spectrum, where there might be something. It may well need something bigger and better than the Large Hadron Collider, because whatever these particles are, they're massive. They're massive. They outweigh normal particles by 5 to 1, as Doug says. So that's one possibility, that we might find a crack in our knowledge of physics, which opens up a new line of research. And then at the end of that rabbit hole, there is plunk. Oh, here it is. At last we found them, axions or neutralinos or whatever they are that constitute dark matter. Or the other thing that might happen is, and people are still looking at this, we might have been barking up the wrong tree altogether. The MOND theory, modified Newtonian dynamics, which was proposed back in the 1980s by Mordechai Milgrom at, I think, Tel Aviv or one of those Israeli universities. He postulated that our understanding of mechanics is wrong, that force equals mass times acceleration doesn't work on large scales. There's a difference in there. And unfortunately, there are all kinds of chinks in the MOND theory, which is why it's not widely accepted. Although I know at least one podcast listener who's doing a PhD on this. Hi, Peter. So there may well be something that opens up that says, yeah, we've just got it completely wrong. And you should realise that scientists are open to that. Most scientists think it is a particle. But if some really strong piece of evidence came up, the scientific opinion would shift, and suddenly we might be looking at, new forms of acceleration or things that don't work in the way that we think they do. So I'm sure we'll crack it, Andrew, but whether space nuts will still be going when we do, I don't know.
Well, I hope so.
Yeah, I hope so too.
I hope
so. A personal message: it's down to you, Peter. No pressure. It's down to you.
No pressure, Peter. No pressure at all. No.
Peter Vermeyen, I give a shout out to him. He's a former technician at Siding Spring Observatory, now doing his PhD on modified Newtonian dynamics.
Well, it's a good thing that science and scientists and astronomers and particle physicists are flexible, because if we weren't, we'd still be making tools out of stone, I imagine, because we wouldn't change our minds about anything.
That's right. Yeah.
All right. Appreciate the question. Thank you, Doug, wasn't it? Doug in Ontario. Let's now go to Sandy in Victoria, who's got a question which on the surface might sound like it comes from the very centre of the planet geekdom, but it's quite interesting.
Hi, Andrew and Fred. It's Sandy here from Victoria again. Thank you for answering my last question. Although I didn't explain it well, you understood what I was trying to say and answered the question, so thank you. To my new question, I have an interest in telescopes and astrophotography, and my question is related to telescope mounts. The German equatorial mount is the preferred mount favoured by many hobby astrophotographers. However, when I was reading about a few of the large professional telescopes like the VLT, they all seem to sit on top of an OLTAS mount. Why is that? Is it simply due to their size? Thank you.
Yes, I thought there was more. Thank you, Sandy. And the answer is yes. And that's all we have time for this week.
It is. The answer is yes.
Oh, is it?
Yeah, it is. So, but look, we should unpick this a little bit for people who have no idea what we're talking about. When you have a telescope looking at the sky, normally in the lower price range of telescopes, although that's changed quite a lot. But let me put it this way. You mounted them on what's called an altazimuth mount, often shortened to an altaz, as Sandy says. So what does that do? Well, it just lets you move the telescope up and down or side to side. It's like a theodolite. So it's, the two axes are, one is vertical and one is horizontal. It's as simple as that. And that's great. I mean, it's very, very convenient when it's well made. But for the most basic kinds of telescopes, it means that when you try and track an object through the sky, you're basically moving it in steps. And I've spent many, many hours with groups of people looking through an altazimuth telescope. And what you have to do is they look through the eyepiece and say, that's fantastic. The next person comes and has a look and says, I can't see anything. And it's because the objects move, because the Earth's rotating. And so then you've got to fiddle around with these steps. And it was a long time ago, actually. It was, I think the first what's called an equatorial mounting goes back to Christoph Scheiner, who was a contemporary of Galileo's in the 17th century. If you mount a telescope, if you build a mounting so that instead of one of the axes being vertical, it's tilted over at the angle of latitude where you are, then it becomes parallel to the Earth's axis. And you've got this really neat trick that as the Earth rotates underneath you, all you've got to do is rotate your telescope about this axis and it follows the stars perfectly. And that's called an equatorial mounting. And if you've got the high-end version of that, then you have a what's called a clock drive, even though these days it's an electric motor that drives it so that it exactly matches the Earth's rotation and the field of view is stationary. And that's what you need for photography, of course, because your exposures might last 3, 4, 10, 15, or in our case, in the olden days of photography, 60 minutes. And you want to be able to track without the telescope, having to be moved. Now, things have changed in the modern era. Let me just mention, though, that until the 1980s, all big telescopes were built, actually the 1970s is probably a better way to put it, all big telescopes were built on an equatorial mounting. That means one with this axis tilted over. And that's why the Anglo-Australian telescope, where I used to work, it's a fork mounting, but the whole thing's tilted over at this curious angle of 31 degrees or thereabouts, which is the latitude angle of siding spring. It was only in the 70s. And actually, the Russians pioneered this with their large telescope in, I've forgotten where it is, Zelenchukskaya, that's the name of the place. They pioneered this because computers could suddenly do this compensation. An altazimuth is much easier to build. Everything's vertical. You've got one vertical axis. The whole thing's not tilted over at some funny angle. And that makes the mechanics of it much more straightforward from a structural point of view. So once computers had got to the stage where they could work out where you have to go with an altazimuth telescope, one that moves up and down and side to side, and then you could do it in tiny little steps so that the whole thing looks as though it's just following the stars. And that's how all big telescopes are built now. It's purely a size consideration. We have the computer technology to do it, and makes the mechanics much easier. Now, that has also spread downwards to the amateur field. So a lot of modern day telescopes are on a computer-controlled altazimuth mount. Many of them are. So why don't we use that for photography? Why do people like the equatorial mount better? The answer is that if you're doing photography with an altazimuth telescope, even though it's got a swish computer control, you've got a problem in that the field of view seems to rotate. And that doesn't happen with an equatorial. So your stars, yes, you're tracking on the stars, you're tracking on the centre of the field of view, but the field is actually rotating very slowly around that. And if you didn't do anything about it, you get lovely pictures with all the stars as little curves centred around the centre. So that's why in small telescopes, the equatorial mounts are still preferred. Sandy mentioned the German equatorial mount. That's a particular name for one that has a counterweight balancing the weight of the telescope. And it was invented by Josef Fraunhofer back in 1808 or thereabouts. The great Dorpat refractor, which is a beautiful old telescope that I've seen. It's in Estonia. That was the first of these mountings. And because it was built by a German scientist, he was in Munich, in fact, it was Fraunhofer, it's called a German equatorial. It's the most common form. So that's the bottom line with all this. Big telescopes use computers. Smaller telescopes can, but you've got to work out how to rotate the field of view, and it's easier to use a German equatorial for photography.
There you go.
Ta-da!
Asked and answered, Sandy, as I say, and great question, and something a little bit different for us to tackle this week because we certainly like to tackle questions from all kinds of angles, and that one had a lot of angles in it.
Indeed.
Dear. But thanks again, Sandy, and thanks, Doug, for sending in your questions. Greatly appreciated. And, of course, if you have questions for us, you can send them to us via our website, spacenutspodcast.com, and click on the AMA link at the top of the screen, and that's where you'll find our email interface where you can, do the old-fashioned email thing and type your question in with a keyboard, or you can use a recorder. If you've got a device with a microphone built in, like a mobile phone or a computer or a tablet or something like that, you can just click on the record button and say, "Hi, I'm Fred from Sydney, and I want to know the name of Andrew's new book and where I can buy it." We will broadcast that question to the entire globe over and over again. But no, that's how you do it. Just click on the AMA tab and you can send us your question there in whatever form you so desire. We look forward to hearing from you. And that brings us to the end, Fred, and thank you again as always. Oh, by the way, there's a new book available at the... I'll stop there. Thanks, Fred. It's been fun as always.
We'll talk next week, and I look forward to it very much, Andrew, as always. See you soon.
Bye-bye. Fred Watson, Astronomer-at-Large here on Space Nuts. Thanks to Hugh in the studio for pushing all the buttons and sending out all the notifications and putting the whole thing together with sticky tape and plasticine and sometimes super glue, which is probably going to be required today. From me, Andrew Dunkley, thanks again for listening and or watching, and we'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.